Okay, this video is over Chapter 7, Section 3, Adding and Subtracting Radical Expressions. So the first thing to notice is you can add and subtract radical expressions the same way that you could add or subtract this, for example, 5x minus 3x. The important thing is that you have the same index on both terms and the same radicand thing inside the radical on both terms. If those are the same, then you have like terms and you can combine it to be 2 times the cube root of x. Okay, so here's another example. Same radicand, same index, it's 2 on both of them, so this is equal to 5 times the square root of 7. Here you have the same index but a different radicand, so you can't simplify this. This is as simplified as that expression will get. Okay, so same index, different radicands, so we can't combine any of these, right? No, because you can actually simplify a few of these. So let's simplify this first. Square root of 18 is the same thing as the square root of 9 times 2, which is the square root of 9 times the square root of 2. And the square root of 9 is 3, so this is the same thing as 6 times 3 times the square root of 2, or 18 times the square root of 2. Plus 4 times the square root of 8. Square root of 8 is the same thing as 4 times 2, so that's the same thing as 4 times the square root of 4 times the square root of 2, which is the same thing as 4 times 2 times the square root of 2, which is the same thing as 8 times the square root of 2. So you can already see we have two terms where the radicand and the index are the same, so we're going to be able to combine these. Let's go ahead and keep working on this last one. Well, if it was going to be square root of 2, it would be 72 divided by 2, which is 36. And 36 is a perfect square, which is nice. And 3 times 6 is 18. So what initially looked like a problem that we couldn't combine, we can actually combine all three of these terms. 18 square root of 2 minus 18 square root of 2, these two are going to cancel out and we'll be left with 8 square root of 2. Okay, let's do another one similar to that, but first we're going to have to FOIL this expression. So we're going to have to multiply 3 times 2 and get 6, and then 2 square root of 5 times 4 square root of 5, which is going to be 8 times the square root of 25, because square root of 5 times square root of 5 is going to be square root of 25. And then here we got 2 square root of 5 times 2, so that's going to be 4 square root 5. And then we have this last one, 3 times 4 square root 5, and that gives us 12 times the square root of 5. So this one can be simplified, and that's going to be 8 times 5. These are like terms, so we can combine those into 16 times the square root of 5. And then 8 times 5 is 40, plus 6 is going to be 46. So we have 46 plus 16 times the square root of 5. And that is what this term simplifies to. Okay, so I believe that's all we need for that one. Okay, now let's multiply these two. Now these are really similar. They look the exact same except for this minus and plus sign. And this is actually a special case, and you'll see why. Square root of 2 times the square root of 2 is 2. Negative square root 3 times positive square root 3 is negative 3. Negative square root of 3 times the square root of 2 is negative square root of 6. So you can multiply two things if the index is the same and the radicand does not have to be. And then this last one, positive square root 2 times positive square root 3 gives you positive square root of 6. These last two terms cancel and you just have 2 minus 3. And that's what your numbers are here. So you get 2 minus 3, which is negative 1. Alright, so this is a special case, and it's called multiplying conjugates. If you have something where the only difference is the sign in between the two terms, two binomials, then when you multiply these, it's the same thing as a squared minus b squared. A squared minus b squared. So here, that would be, I'm sorry, not a squared, a minus b. It's that first term squared, which is just a, minus b. So in this case, that simplified to 2 minus 3, which was negative 1. Alright, so that'll help us here. If we want to simplify this by rationalizing the denominator, what we're going to do is we're going to multiply this fraction times 1, but a special 1 plus the square root of 5 over 1 plus the square root of 5. So this fraction here is equal to 1, but also it has a nice property that it's the conjugate of the bottom term. So when you multiply two fractions, you would multiply the numerators and you get 3 plus the square root of 5 times 1 plus the square root of 5 over 1 minus the square root of 5 times 1 plus the square root of 5. Alright, so we have conjugates on the bottom that we're multiplying. And so we're going to get 1 squared minus the square root of 5 squared on the bottom. And on the top, we're going to get 3 times 1 is 3. 3 times 5 is 3 square root 5. Square root of 5 times 1 is the square root of 5. And the square root of 5 times the square root of 5 is 5. So we can simplify this a bit. That's the same thing as 3 plus 5, which is 8. And 3 square root 5 plus the square root of 5 is 4 square root 5. And then on the bottom we have 1 minus square root of 5 times square root of 5 is going to be 5. So we have 1 minus 5. So I'll write it over here actually. We have 8 plus 4 square root 5 over negative 4. And this can actually be simplified. So let me get a little bit more space. I could rewrite the top as 4 times 2 plus the square root of 5. And then I have over negative 4. These are going to cancel out, and I'll just be left with negative 1, or negative 2 minus the square root of 5. So that's what this problem simplifies to. And that's it for lesson 7.3.